Welcome to the office. We want to take a look at one more example here for section 11.1 on three-dimensional coordinate systems. For this example, it's going to take a little bit of thought. Okay, we're looking to minimize something, right? We have find the point on the sphere which is nearest where we're going to minimize. Right, being a calculus course, we would expect to have differentials, right? Take a derivative and um, find the critical points and whatever else. Right, so we can find the maximums and minimums. But that's not really what we're interested in here. We just want to understand the geometry, right? The geometry of space. We're not super worried about the calculus of space yet. So we want to find the point on the sphere that's nearest to these two things. And it works out that these are both very specifically chosen to make things relatively easy. So let's go ahead and attempt to get a visualization of this sphere and then think about the XY plane and where this point lie with respect to that sphere. If you wanted to use GeoGebra, you could do that. But what I really want you to be able to do is to think about what these things look like without relying on that technology. Where is this sphere located? What is the radius? How does that interact with the planes? That is, does it intersect the planes at all? Not that you have to know the intersection points, but just an awareness of whether it intersects or not. So if we recognize this as x squared, right, x minus 0 squared to be even more explicit, x minus 0 squared plus y minus 3 squared plus z minus a negative 5 squared. Getting that subtraction so I can correctly identify the center is equal to 2 squared. So this identifies for me the center, which is 0, positive 3, because it's subtraction there. So 0, positive 3, and negative 5. And we have a radius of 2. So let's go ahead and try to plot these points. Since the center is has a z-value of negative 5 and the radius is 2, I know that that's going to be below the xy plane. So we have z, x, and y here. So I have 0, I'm going out by 1, 2, 3 in the y direction, and z in the negative direction, I'm going down by 5. So 1, 2, 3, 4, 5. So we'll say that the center of the sphere is right there. Now what I'd like to do is I'd kind of like to just put some arrows out to the maybe what we want to call the cardinal directions of our sphere. Cardinal directions really refer to north, south, east, and west, which makes more sense in 2 dimensions. But I know that since I have a radius of 2, I'm moving up by, approximately 2. So I'd go straight up by about 2, straight down by about 2. So that gives us positive and negative z-axis. Reach in the positive x-axis by 2, negative x-axis by 2, negative y-axis by 2, and positive y-axis by 2. And so this is going to give me a way that I can kind of mark out some of these things. I'm going to zoom in a little bit so I can attempt to get a good visualization. So I have this XY plane sort of circle that a great circle that I could draw. Okay, I have this, that's not great. Let's try to pass through all of the endpoints there. That looks good. So that's a flat circle, XY. Okay. I also have this circle that I could draw. I could try to draw the YZ. So it would look like this. And then I could draw the XZ, which would look like this, kind of. Now it gets complicated and messy when you draw 3 of them. So what I like to do is I like to just draw the one that's horizontal. Think of the equator. And then what does our sphere look like? Right, that's our sphere. It's not the best sphere ever, but that's fine. Not a big deal. I'll zoom out a little bit again. Now, if I'm looking at the XY plane, right, I'm looking at this XY plane. Well, this whole thing is below the XY plane. So the point that is closest to the XY plane is actually just the point that's on top. So if I go with, well, let's use green here. So right here, the top of the sphere is closest to the XY plane. Now, because I know where the center is, 0, 3, -5, and I know that the radius is 2, I can simply move up 2 from the center, and that gives me the top of the sphere. So the top of the sphere is closest to the XY plane, and that would give us an X value of 0, a Y value of 3, and I'm moving up by 2 from that, so I move from a -5 up to a -3. Easy enough. Now what I want to notice is that the point 0, 7, -5, 0 in the x direction, 7 in the y direction. So if I move over by 7, so this is 3, 4, 5, 6, 7, and then go down by a -5. 1, 2, 3, 4, 5. That's right there. This is actually just a direct move in the y direction from the center of the circle. So that's actually going to identify for us exactly what that point is. So this point, let's see here, I'll use green again. This point right here is going to give us, so that distance is minimized. The point with the highest y value on the sphere is closest to the point 0, 7, -5. Again, because this is simply move from the center of the sphere to in this direction, right, in the positive y direction, then we're just looking for the point that has the highest y value there. Of course, that's just moving by the radius out to that point. So 0, our center is 0, 3, -5. If we move by 2 in the y direction, that would increase our y value by 2. So that's going to be the point 0, increase the y value by 2, and then -5. Right? We're not moving in the x or z direction, just in the y direction. Move in just the y direction to get to there. So that's going to be the closest point. Will we be able to answer these questions with calculus in some sense later on? Yeah, definitely. We'll use the distance formula to be able to do that. But for now, this is all that we're looking for. So thank you for your time and your attention. That's all that I have to share for our introduction to the three-dimensional coordinate system. So I'll see you guys later, either back here in the office or in the classroom. Have a great day.